Lads, first of all, just going to open up a blank screen, all right? Something squared, doesn't matter what it is, always bigger than or equal to 0. Has to be. You got it? If I put a minus 5 in here, what's the answer? 25. If I put a 0 in here, 0. Is that cool with you guys? All right. Next order of business. Minus something squared. What is that? It's always negative. Why? Yeah. So it's a positive answer times minus 1, which is always negative. Okay, let's move on. 4 plus something squared. Always positive or what? What's the crack? Huh? Always positive. You agree with that? All right. Now here's the problem with this one. 4 minus something squared. It's both, isn't it? Because example, if that's 2 squared, the answer is 0. If that's 3 squared, the answer is negative, isn't it? And if that's 1 squared, the answer is positive. So this one can be positive or negative, depending on what's going on. Does that make sense? Now, what we're going to do here is they're going to give us some random equation and they're going to ask us to prove that it's always bigger than the other side. In all of these questions, without fail, you're going to set up a perfect square somehow. Somehow, some way, you're going to set up a perfect square. So I'll show you the very first one. Very bog standard question, all right? You throw over you bring over the 2xy. Everybody cool with that? Now, for those of you that aren't too good at factorizing, lads, for those of you that aren't too good at factorizing, pretend that the y's don't exist, right? And what would it look like if the y's don't exist? Plus 1, yeah? If you factorize that, it's x minus 1 times, but the y's do exist, so what do you think it is? X minus y and, yeah, is that right? And if I was to multiply that back out, what would it turn back into? Yeah. Who doesn't know how to do that? Sorry, I'll pause here. Let's look at this. It's a perfect square, isn't it? And a perfect square is always bigger than 0. So I've effectively proved that question. Okay. Now, gets obviously a bit more difficult later on. You might think something like question 5 looks like a standout, doesn't it? Well, the fractions. Would you agree that question 5 looks a bit more? Yeah, all right. It's not great looking. All right. So let's see what we can do here. All right. Now, lads, let's sort out the problem. I think that part's the problem. Do you? Would everybody agree with that? Okay. And where possible, we try not to deal with fractions. All right. What can I do here? Everybody cool with that? Would everybody be happy with y plus x over xy? Would everybody be also happy that, yeah, we're good there. Now, look at this. Now, what's that then? Y plus x all over xy. Now, not yet, because I have to do it to both. I have to give a common denominator to both sides, don't I? Now, here's a problem. That xy, that could be positive or negative, could it? Is there anything in the question that eliminates it from being negative? No, no, no. Imagine for argument's sake, x was minus 3 and y was 2. That'd be a minus 6 on the bottom. And if you multiply it by minus 6, the sign changes direction. There you go. They're both natural numbers. See that part there? That means xy has to be positive. Why? 1 and above. All right. So that means I'm allowed to multiply both sides by xy to give a common denominator. Is that all right? Does this part here need a common denominator? Why not? It's been multiplied. No, that's not the answer. Do I have to put an xy here and an xy here? Why? It's been multiplied and the xy is already underneath it. Is that right? So we're going to get xy plus x squared plus y squared plus xy squared equal to 4xy. Bring it over to 4xy. What happens to it? So it's going to be xy minus 4xy plus another xy. And long behold, you're stuck with the same thing you were stuck with last time. This is literally question 1 all over again, isn't it? So it's just going to turn into x minus y. All right. All right, give you guys one to do. Oh, this is bad. Right. Right. Question 7. I'll give you one hint for question 7. You ready? I'll give you one hint for question 7. Okay. Here's the cheat code to question 7. Okay. Do you remember we had a? Do you remember we already did this? X squared plus 2xy. Yeah. Now there is a cheat to this, right? No, you won't think of it unless you've seen it before. You won't think of it. Okay. Only reason I know this is because I've seen this question a lot before, and I learned off what happens when I see it. See the first two of them. I have to turn it into a perfect square, don't I? Now, imagine what x plus y squared would look like. What does x plus y squared look like? X plus y, doesn't it? And it turns into x squared plus 2xy. Okay, stop there. You don't have y squared. What do you have? Huh? You have 3y squared. So what am I missing out on? Well, I'm missing 2y squared, haven't I? Would you agree with that? Now, here's the trick. What did we say this part is again? That is a perfect square. And what's that? What's y squared? No. Y squared is a perfect square. Think about it. Any number squared is positive. So see that blue part there? That has to be positive. Why does it have to be positive? Yeah. And what about this part? Is this also positive? Yeah. So what does that mean about the overall answer? All of it's positive. So that's a positive number and, yeah, which is greater than or equal to 0. You. All right. Everybody look up. A squared minus b squared is a minus b by a minus b. Square that out. You're going to get a squared minus ab plus b squared. Okay. On both sides, you'll see an a squared. Okay. The a squareds cancel. Oh, sorry. The a squareds do cancel. Sorry. This one here and this one here. Great. Now, here's what we're thinking. Bring the b squared to the other side. Minus 2b squared. Bring the ab and the ab over to the other side. 2ab. Now, guys, this is really tricky, right? Now, let me explain something. Read the description of the question. A is bigger than b is bigger than 0. For argument's sake, a is 3, b is 2, and they're both bigger than 0. Is that okay? Now, check this out. 2 times 3 times 2. What's 2 times 3 times 2? 12. Okay? And what would be 2 times 3 times 3? No. 2 times 2. B is 2. See the way B is 2? So what would that be? 8. Now, you can divide both sides by 2 if you want, and you get AB is AB minus B squared. Is that okay? You can bring the B squared over to your side if you want. Can anybody tell me? Oh, it's really easy now, actually. So just give me a sec. Am I allowed to divide both sides by B? Yay or nay? I'm allowed because B is positive. Example, 6, 9 is bigger than 6. Divide both sides by 3. Divide both sides by 3? Absolutely. Yeah, so I'm going to divide both sides by B because I know that B is a guaranteed positive number. So is A bigger than B? Yeah. So this means this whole system is true. And I've proved.